Tonight, the material we cover is not going to have an assignment from it, but if you guys follow along, if you do the assignment that we're doing and you want to turn it in, you can get some extra credit points for doing it, but it's not mandatory. However, the information that you'll learn tonight, I think you'll find beneficial for sure. So before we get started, does anyone have any questions or about anything, the labs or the class or whatever? Before we get going. Okay, well, if not, like I say, tonight we will venture off into the wonderful world of Objective-C. So you can either, if you want, you can follow along, like I say. You can do the assignments. Not a bad experience. I mean, not the assignment. You can work along with me in class. It's not a bad experience to do. Otherwise, you can just follow along, relax, and enjoy. I think if nothing else, you'll gain an appreciation for Swift once you start working with Objective-C. So anyway, if there aren't any questions, we'll go ahead and get started. This will probably not last, as long as usual. This may go like an hour and 20 minutes or so. Shouldn't be too bad. Depends on how quickly I can fumble through Objective-C syntax. I think I'll give you guys kind of a little bit of an overview of the syntax, so you're not just, rather than just tossing it at you. We'll kind of take a look at it in comparison, and then we're going to implement a Swift class inside the Objective-C project, and so you'll see how you call Swift class methods from a Swift class from Objective-C. So I'm going to create a new Xcode project. Single view. We'll call this C to Swift. The language this time, however, I'm going to set to Objective-C. Everything else stays the same. And create. Okay. So right off the bat, things are pretty much identical to if you created a Swift project. If you go into the main storyboard, once it's ready, you'll notice it looks pretty much identical to what you do if you're in a Swift project. So some of the similarities. So storyboards are common to both languages. A lot of the properties, everything you can set is pretty much the same. If I select the, you can see over here in the view controller scene selection, you have the same properties, the same basic layout. So you got the view controller at the top level. You get your layout guides. You got the view inside of the view controller. So same entry point. Your entry point comes in through the storyboard. So everything is pretty much the same. Outlet, the view is hooked up in the outlet already. This is going to be a UI view controller. You can set the size attributes like you would normally. Set to a 4-inch phone. You can set, whatever size you like to set it to. I generally try to set this to the minimum size I know I have to support, but for tonight it really doesn't matter what you use. But if I go into the app delegate, one difference you'll notice with an Objective-C app as opposed to a Swift app, and if anyone's done any C or C++ development, this would be very similar. You have a header file, so you notice there's an app delegate class just like you normally have, but instead of just having an app delegate.swift, you have an app delegate.h file. This is called the header file. And in here, instead of the usual import, you have a pound import, and then you have curly brackets instead of just using regular notation like you normally would use. You have these brackets. That indicates that this is a system library that you're importing as opposed to one that's local to the project. And then you have the header file. Header file lays out, so you can see in here is the window. This is the main UI window that you work with. That has that automatically built in. The class that is derived from is the UI responder, and then it implements this delegate. So delegates have brackets around them instead of just a comma after the So in Swift, you'd have the UI responder, comma, and then UI application delegate. In Objective-C, you have the name of the class it's derived from, and then the protocols are in brackets like that. Properties are defined like you can see here. The storage type, whether it's atomic or non-atomic, just all basically relates to the way that it's managed in memory. So that is the interface to the class, the definition, the template, so to speak, and then the implementation file is in the .m. You also have, you notice in the header file, you have this interface definition here. So this is like the public-facing interface. This is what's exposed to other classes. So this is what's available for the general public to use, what's in here. If you go in the .m file, there's also an interface defined up here. This guy is only available to itself and derived classes. So the interface that's in here is not public, it's private or protected. And then there's the implementation. You have the application did finish launching with options like you normally would have with Swift. It looks a little bit different. In Objective-C, instead of a regular like in Swift, you'd have like a bool for a return type, and of course that'd be at the end of the function declaration. And a bool is a true/false. In Objective-C, it's a capital all uppercase bool, and they use a yes and a no to mean true or false. The way it's defined is kind of similar as far as the function declaration. You have the application in this case. So this is, you've seen this with like table views where you have table view colon. But in here, this is a little bit different. So in a Swift app, you would have variable name, and then you would have colon. You'd have inside here, you'd have variable name, and then the type. In Objective-C, you have the type, and the star there just means it's a pointer. So pretty much any object in Objective-C is a pointer. And then you have the name of it outside of the parentheses, so the actual variable name is application. And then did finish launching with options. This is an NS dictionary pointer, and that's the variable name is the launch options. Okay, so a little bit different, but the actual function names, the method names, the delegate protocol names are all the same. So the actual declaration is not different. It's just the way parameters are passed into it and stuff. And then the return types are at the beginning instead of at the end with the arrow. So same thing is true with our view controller. So our view controller, like I say, is derived from UI view controller. Again, we're importing the UI kit in the M file, implementation file. We have the same methods that we had with Swift. We have viewDidLoad. It calls the parent method. Its parent's class is viewDidLoad. So one significant thing with Objective-C, a little bit weird, are these brackets. So normally you'd use these guys as an array notation, an indexer. In Objective-C, this actually denotes a method call. We can say, I can put a bracket here and say self, and then here's all the variable methods that are available because I started a method declaration. And so now here's all the methods that are available. And it knows that I'm calling a method because I started with an opening bracket, I typed self, and then space, and then started a word. So normally in Swift, of course, you'd say or self dot. In Objective-C, all that's going to give you are the properties that are available, not the methods. So a method is declared with these brackets. Same you can see down here in the did receive memory warning, all that kind of stuff. So Objective-C methods always are bracketed like that. And then depending on whether or not it has parameters, then you have the colons and all that good stuff. Okay, so that's some basic syntax stuff. Interface declarations that are in the M file are private. Ones that are in the header file are public. All right, so we can start off. We can do some stuff in our view controller. What we could do, actually, let's see, I think what we'll do first is, before I continue on with the view controller, let's go ahead and I can go ahead and run this. Set this to a 6, maybe a 5S. I'm going to run it. If you have any questions as I'm going along, just go ahead and ask. All right, so while we're waiting for that, that should already be running. So I'll go ahead and just do a real quick something in the view did load so you can see it. So what I can say is self.view.background color equals, and I'm going to call it UI color method. So I have to use the brackets. I'll say light gray color. Also in Objective-C, you have to terminate statements with a semicolon. It's not optional, it's mandatory. All right, so there's our view. Now I changed it so we have a light gray background color, so I can build and run it again. All right, so now it's got a light gray background color. All right, so a basic Objective-C syntax. What I'm going to do now that we have this basic functionality set up, I'm going to swap out the view that comes prepackaged, the standard UI view, for a new UI view, something we've done before. But this is going to be a Swift-based UI view instead of an Objective-C view. So to do that, I'm going to do like we normally would do. Go up to the top file level and say new file. It's going to be a Cocoa Touch class. And this guy is going to be a Swift view. And this is going to be a subclass of UI view. And language, we're going to go with Swift. Okay, I'm going to go next. And create. Okay, now, as soon as I do this, you'll see this handy dandy little pop-up comes up. It says, would you like to configure an Objective-C bridging header? And then it gives you a little explanation. Adding this file will create a mixed Swift and Objective-C target. Would you like Xcode to automatically configure a bridging header to enable classes to be accessed by both languages? You always, 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 always want to say create bridging header. And this will wire things up for you. If you don't do this, I think you could probably go back and do it later, but this does a really nice job of creating the bridge between the languages. And also you will notice that it created this goofy looking file over here, this obc to Swift bridging header.h. So this file allows Swift to communicate with Objective-C. But in addition to that, I will go into the project settings. If I go into my build settings and search for Swift, down here you see the obc to Swift bridging header .h. What we're also going to do is utilize, actually the main thing that we want to utilize is going to be a Swift.h file. Which I'm not seeing, possibly because I didn't build it yet. Okay, so well, we'll see what happens here. I think I was expecting to see an obc to swift-swift.h, but it's possible that that guy doesn't come along until we actually integrate it. So what I'll do, all right, so we have this new file, the swift view.swift. This guy is going to be our view for our main UI view controller. So now we have to hook it up so that it's so that you can utilize the new so the view controller, which is Objective-C, can call this guy and set it. But first thing what we'll need to do is in our storyboard here, our view right now currently is a standard UI view. So what I'm going to do is change this to be our new Swift view. Okay, so that tells it we're going to use this class we just created. Now in Swift view, if I go back into that, you notice we have this draw rect function, which we've seen before. This is what gets created. They gave us this kind of boilerplate template for us to use. I want to uncomment this guy. So this allows us to do custom drawing code and stuff like that. All right, so this will be the view that's going to reside inside our view controller. So in here, what we can do is we can create some custom drawing code so that we know that, in fact, this is the view that's being created. So I'm going to close the door. Like all kinds of busting. All right, so in the draw rec, this is the thing we've seen before where this gets called in a custom view so you can do your own drawing code. So what we can do, now we're back to Swift syntax. So we can declare variables like we normally would. This is all just normal Swift code. So we can say let increment equals UI screen dot main screen dot bounds dot size dot width, and we'll divide this. We'll just go with this for now. Divided by, so I'm going to divide this guy by, say, 60. Yeah, 60. All right, so what we're going to do is I'm just going to create a series. I'm going to draw a series of like red balls running across the screen in this view. So we can tell that this is definitely our view. All right, so this is going to be some drawing code like we've done before. All right, so we can say for I in 0 to, we want 0 to be less than, I have to create an int from our increment because this needs to be an integer value and this guy is a float. So we're going to increment across our screen and we're going to create, we're going to create these balls. All right, so each one of these, so if our screen is, say, 420 pixels wide, this guy should be 7. All right. So what I'm going to do is create an exposition for this. And I'm going to say I times 60. Actually, all right, so I'm already thinking of Objective-C syntax. That should be let. No, no, no. Okay. Okay, so let exposition equals I times 60. So we start off, it'll be 0, so it'll be right on the left-hand side, and then it'll increment to 1, it'll be over 60 pixels. So then we're going to make these balls at the top. I'm using this incrementer. Let me say let R equals CG rect we're going to make this guy at X position. Oops. And then Y, we'll make it like 50, make it at the top of our screen. Width can be 40, height can be 40. So now what I'm going to do is I'm going to create a Bezier path. I don't know if you guys remember the Bezier paths. We're going to create a Bezier path that's basically a circular path, and then we're going to draw a circle, draw that circle, and then just fill these guys across the screen. So create a UI Bezier path from our, make an oval in rect as the one that allows us to creates a circular Bezier path. Pass in that rectangle we just made. Then we can say let C equal UI color dot red. Make it red balls. You can make whatever color you want. C dot set fill sets the fill color, and then we just say P dot fill, and that'll make the ball. So if this guy's hooked up correctly, then we should be able to run it and see those guys fill across our screen. Okay, so there they are. All right, so what that tells us then is clearly our Objective-C app is using our Swift class that we created, and the view controller in here is sets the background color on the view, and that view now is a Swift view that we created. All right, so that all is working as intended. Okay. All right, so the next thing we can do is we want to actually demonstrate our ability to call this Swift view from our Objective-C code. All right, so to do that, we'll need to create an init method, and the init method will allow us to call it from Objective-C. Right now, we don't have a constructor on this guy, and Objective-C really likes to have constructors defined to be able to create stuff. So I'm going to go back in here now. Okay. Just looking to see how this is set up. All right, so we'll have to use this bridging header probably. I'm just going to try something on my view controller. So in the view controller, there's a couple of things you can do. If I wanted to make a member variable of the view controller be my class, in order to do that, generally speaking, you would declare the variable in your implementation file, and in the header file, you can do something what's called a forward class declaration. So I can say something like this. Swift view. Now what that does is, now if I want to, I can create a property of that type in here. Say strong, non-atomic, and this guy will be a Swift view. Okay, now I have not told Objective-C about this class at all yet. It knows nothing of it. But what I've done is I've created what's called a forward class declaration right here, where I've said, okay, there's this class, it's called SwiftView. I haven't defined it yet, but trust me, it really exists. And so I can actually go ahead and create a property of that type. Even though I have no definition for SwiftView, it's fine with it. And then in the implementation file, up here, I would add an import. And the import I'm going to add, I don't want to use the, let me just open this guy up. Yeah, that's what I thought. All right, so in the implementation file, what I'm going to do is say import Swift, oops, Swift view, Swift, I could type .h. And let's see here. I'm just going to go ahead and do this anyway. I'm going to clean it first. Then build it. Yeah, I'm still not liking that. It's really weird because usually it will create that file for you. I can try using the bridging header instead. Try this guy. But I don't think that's going to work. Plus, I'm going to do just out of curiosity, do a file new. Make this one Swift also. Some other view. I'm going to create. Okay. What I'm trying to figure out is we should have defined this file. So the bridging header typically will allow us to bridge from Swift to Objective-C, but to get from Objective-C to Swift, there's usually another file that gets created that would be like the name of the project -swift.h. So I'm going to go back into my view controller. Sometimes it's hidden, depending on your settings. And the reason I think maybe this is not working is because I named it wrong. It should be obc to Swift -swift.h. Hope we can find that. Looks like maybe it's good with that. All right, so this guy's out there. It just, unfortunately, is not visible to us for some reason, but what I can do is I can click on this and go jump to definition, and then you get this little bundle of ugliness. So what this is, basically, is this is like the OS's little link or tie between the two languages. So this is the way that Xcode basically defines a Swift class in Objective-C notation. So it's got like a combination of Objective-C and a lot of C code. So you can see all these type defs, these ifs, end ifs, all this kind of stuff. All this kind of stuff are preprocessor directives and C code and pound defines and stuff like that. It's all just straight C code. These are C macros. All this stuff is basically, so here's our some other class that I created. This is the definition of it. So this is how, when we call it from Objective-C, it's got this class defined. Here it's got the interface. So basically it takes our class definition, and as we add things to it, it plops stuff in this file and defines it in Objective-C terms. So the Objective-C class will look into this thing, pull out the definition, and be able to call it. Here's our Swift view down here. Okay, so that's basically the linker between Objective-C and Swift. Now the other way, the Swift to Objective-C to Swift is done with this guy. So we don't probably really need this one. It's handy to have, but the one that we're really concerned with is that other one we were just looking at. That Usually they have that in the build settings. You can see it actually defined in there. For some reason it's not showing up in there. It could just be the way Xcode's configured. So the way you can get at it is, like I say, you just select that, right click, and jump to definition, and it takes you into it. If you really want to look at this stuff. So it's some pretty ugly stuff in there. All right, so now if we go back to our view controller file, and again, you don't need to worry about this once it's created. That file we just looked at, maybe by default they don't have that set as visible because the compiler and the runtime basically manage all that stuff. So if you add that, if you click on the add bridging header thing when you create the Swift class, that's the reason why you really want to click on that, because it also creates that other file you just saw. And if you didn't do that, like there have been times where when we were creating new classes at work, it was not adding them into this automatically. So we had to actually manually come in here and edit stuff. So that's really not fun. So anyway, yeah, always click on that little box, that little checkbox that says Add Bridging Header, and then you don't have to worry about that kind of stuff. So what I'm going to do now that we know we've got that link available, what I could do is I could create a variable of type SwiftView, but in order to actually be able to instantiate it in Objective-C, we have to create init methods, because Objective-C is, like the predecessor, and everything in Objective-C, when you create a class, you create an initializer or a constructor for it. So that's what we need to do now, is we need to go back into our draw view or our Swift view and create an initializer for this guy. All right. Does anyone have any questions before I continue on? Would anyone like to be the person who would create one of those files by hand? If you could, that'd be pretty amazing. Like if you had that skill, I don't know, how usable it'd be, but that'd be pretty awesome. All right, so what we need to do now is create an init. So we've seen these before. So what we can do is I can just call super.init, passing in our frame, gets passed into us. And it needs an override. And it probably wants the other one, the NSCoder one. Yep. All right, so if I go ahead, I'm going to go ahead and run this. And what I'm going to do is, in my view controller M file, I'm going to come in here and say, if I could type. So here's our variable declaration in Objective-C. You use the type name, asterisk indicating it's a pointer. I'm going to do a Swift view again. Having problems with typing tonight. Alloc init. All right, now you notice that it has no problem with it. So I just created a Swift class in Objective-C. And then I can say something like Swifty.background color equals UI color, red color. I actually want yellow color. Again, with our really happy Objective-C syntax with the brackets. All right, so I'm going to put a breakpoint here and run this guy. Oh, and look at what we got there. Got a fatal error. I think a few of you might have seen this before, the red bar of death. All right, so the red bar of death is here because of the fact this has not been implemented. It's just reading our fatal error that we just generated. Okay, so when here's a little, the reason behind this is that when you create a Swift class that is being initialized from Objective-C, it's using this way of initializing it because it's using a decoder to create the class. So because the class is from a different language, it has to use this guy. It's just like when it initializes from something that's stored as JSON or something that's stored as text. The way it basically materializes the class is it decodes it. And the same thing with Objective-C. If you've got a C class or a Swift class, that's how it creates it, is using this init with a decoder. So we need to actually implement this guy. In the past, we're just like, yeah, whatever, we just got to have it in here, but I'm not worried about it. In this case, you actually have to implement this method because of the fact we're bridging languages. So to do that, not too difficult, you can just call super.init. I'm passing in the a decoder. And then I'll run it again. And here comes our Swifty. Not a problem. I didn't actually do anything more because this our view is already defined in the storyboard. So in the storyboard, we already defined our view as Swift view. So if I create another Swift view, basically I'm creating two views. I just wanted to show you guys how you'd go about instantiating it. So what we can do, though, is I don't need to do this. I can say Swifty equals self.view, and I'll have to typecast it. So if I was in Swift, I'd say something like this, as Swift view, like that. That would be how I do it in Swift, but in Objective-C, we have to do it differently. We do this guy with a pointer. Everything in Objective-C is a pointer. Not like UWSP pointer, but like a memory pointer. So this is actually a variable, a reference to a memory location. So you're starting to appreciate Swift a little bit, huh? All right. So Swifty is our view. Now I can set it to yellow, and this should, unless I grossly overlooked something, this should work. Again, I'm going to go ahead and debug it. I'm going to run through it. All right, and let's see what happens. All right, so that worked fine. So in here we've got a blend of calls. So we have the view controller setting its view, which is a Swift view, setting the background color to yellow, and then the actual view's drawing code. And there we're making those red balls across the top. And so it all comes out in one happy, wonderful world. So that's all good. Is everyone following along okay? You don't need to worry about that file we were looking at earlier. The only thing you need to know is what it's going to be called. So if you have an Objective-C project with a Swift file in it, and you do that bridging header thing, that little piece of magic, that guy is always going to be the project name -swift.h. And then you have to import that into your Objective-C class that's calling the Swift class, and then it will have knowledge of it. This guy that I did in here, this forward class declaration, I just did this for fun. We don't really need this, but this is how you can do a forward class declaration that allows you to put a variable into your header file without it being defined yet. So what I can do is say this actually. This is like a local variable. I can change this because I declared a property. I can either do this, or I can do, so what this means, in Swift, a property variable is just the variable name. In Objective-C, if you have a property, like we have defined here, this guy here, you reference it either by saying _Swifty or self dot. Like that. Let's see if that shouldn't change anything. Yeah. Clear as mud. All right, so yeah, what you missed, Valerie, is at the beginning was we were just going over created a Xcode project and then added a Swift file to it. So you missed a little bit of the Objective-C stuff, but basically the main thing is that you can do this when you create the Swift file and you add it to an Objective-C project. We just do it the way we just did, is just you do it like you normally would add any file. You just do new file, and then you just specify Swift as the language, and then it does that. Okay. So that's that. Now, the other thing is you may want to call methods on a Swift file, Swift methods from Objective-C. So far, all we've done is we created a view. We made that view the view of the Objective-C view controller, and then we set the background color, which is just a built-in method. So, but what we can do is we can actually define our own methods in our Swift class and then call those guys from Objective-C. All right, so I'm going to create my own specialized function. I will call this guy draw a ball. And we're going to use, so now we're back to Swift syntax. X will be an int. Y will be an int. So we're going to draw a ball at a designated location. And radius will also be an int. All right, so we have this method on our view that says, draw me a ball at this location, and then we're going to call this from our view controller. All right, and then we can also hook up a method, like a button press method, to go ahead and do that too. So we'll create another thing we can do while we're at it, since we're going to create methods, is I'll show you how you create IB actions and stuff like that, IB outlets in Objective-C. So we're going to have a mix here. We're going to have a mix of things. I'll have a button that you can press that just does strictly Objective-C stuff, and then another button that'll call this guy. All right. So if we go back into our storyboard, this works the same as it does in Swift. So you have your library of objects over here. I can drag a button over here, and so we have the button. Let's say something. Works like it normally would. We can go ahead and create constraints with it. Center it. Okay, so this guy will be our Objective-C function. Now, what I'm going to do is create an IB outlet for this. So, normal case. So here's our system editor. Works similarly in Objective-C with one noteworthy difference. If I click on this, it comes up here and it gives me my view controller. Now, if I want to control drag over here to create, like, say, for example, an outlet, you'll notice that the only thing that's available up here is an action. I can't create an outlet. The reason for that is that this is the implementation file. So the implementation file does not have publicly exposed member variables. So if I want to create one of those, if I want to create an outlet, I need to go into the header file. So I can do it this way. You see the little number 4 up here. So here's our Swift view. I don't want that. I certainly don't want that. All right, so there's our UI view. So it's not giving me the header file, but what I can do is go back to this, and then up here, my view controller, I can say jump to definition, and here's my view controller interface. So what I can do is do a control drag from here to here in my header file, and now I can create an outlet. Actions are also available, so this, if I create an action here, okay, then IB action here, this would be publicly exposed, so it can be called from anyone. As an outlet over here, this is also part of the interface file, and anytime you create an outlet, you have to do it in the header file. You can't do it in the .m file. So there's a few extra rules with Objective-C between the header file and the implementation file that don't exist in Swift, because in Swift you just got a .swift and that's it. So we'll call this button hello or something like that. Okay. Now, if I switch back to my implementation file, not that, there we go. If I come back in here, now I can create my, do my IB action. So I can do a control, drag up here, create my action. My action will be button hello pressed. Changes from an ID. So an ID in Swift, if you have a generic object type, that's called an any object. In Objective-C, and any object is the equivalent of that is an ID. An ID is just like a generic object. So I'm going to change that to UI button and connect. And there's my IB action with our Objective-C, our beautiful Objective-C syntax. So name of the method, colon, type that's being passed in, UI button pointer, and the name of that is the sender. Okay, so in here, this is where we're going to create our magic. Get rid of that. All right. So button hello pressed. We're going to do something like we did, and we'll keep this relatively simple, although it's not going to seem simple. We're going to do something similar to what we did early on with Swift. We're just going to create a alert controller and pop up a message for the user when they press this. And you'll see the difference here with the syntax. UI alert controller alert equals UI bracket UI alert controller alert controller with title, message, and preferred style. Yep. Okay, so this is going to be our Objective-C alert controller. So in Objective-C, so in Swift, you can just do something like this. You say let s equal hi. All right, that's a string. In Objective-C, it's almost that easy, but with Objective-C, a string literal is defined with an ampersand, because that just makes perfect sense. And we can say hello here. That's our title. Message will be hi from Objective-C. Preferred style is, this is yet this big long name, UI alert controller style alert. As you can just never get too many words in a description. And a little bullseye. Forgot my little ampersand guy. So for those of you that are coding along, if you need more time to do this, let me know. I also said, Valerie, that if you guys actually want to do this in class, follow along with me, and then turn it in, I'll give you some extra credit points for doing it, but it's not mandatory.
Can I turn it in a little late?
Hmm?
Can I turn it in a little late?
All assignments are due by the end of the semester, despite what I might have previously put in.
Not tonight.
Just not tonight. No, it's fine.
Okay.
Yeah.
Cool.
So there's our UI alert control. So there's the syntax. You always define the type and name first, and then you set it equal to this initializer. I did not have to do an alloc on this guy. There are some, so like for example, as an example, this ns string is a variable that we've seen before. You can do this ns string alloc init. Okay, so a lot of Objective-C classes have this pattern to them. You do an alloc, which basically does, it's like a new in C#. It does a new on it, creates a new version, a new instance of an string, and then init, which calls the constructor. So all alloc does is just create memory for it. The init actually initializes it using the constructor. Okay, so a lot of Objective-C classes have this style. There's a few, like the alert controller, that allow you to do that all in one call. With this alert controller with title, it does the alloc behind the scenes and the init, so you don't have to do all that. And this syntax here, so this is one method call. This is the first method call, alloc, and then this creates the memory that then gets passed into the, or then calls the init method. So you got basically a function inside a function. All right, so we have that. Now with the UI alert controller, we have to create, if you want buttons on that, we could just pop this thing up, but there'd be no way to dismiss it for the user to get rid of it. So we have to create an alert action. UI alert action. And this guy can be done with something similar. UI alert action. Action with title. Yep, that's the guy. All right, action with title. This is the button that gets created in our alert. Style will be UI alert action style dot alert, so it pops up as an alert. And then the handler. So this guy's a little weird. In Objective-C, these inline handlers, what we call completion handlers in Swift, are called blocks. And the way you define a block is with this caret thing. Who comes up with this stuff? I have no idea. But you use this caret, and then after the caret you have the parameters. And actually, that goes in there like that. And then we have an opening curly. And we need a semicolon at the end of it all. I'm sure that makes perfect sense. All right, so again, similar to the UI alert controller, it has this initializer / allocator all in one. Creates it with a title, style, and then the handler is this block of code. So instead of having a completion handler, this guy has a block, which is denoted by this thing. And that basically says, okay, everything that comes after my little caret here is a method, an inline method. Okay, and then in here we can do something. All right, so let's do this. In here, what we can do is once they press OK, we'll say, so this is after they pressed OK, this is the handler. Self.view.background color, we'll change it again, equals bracket, UI color. We're yellow now, okay, orange. Make this as gaudy as possible. So everyone will want to use it, and oh wait. Background color, was it not like? Oh, I know what I did wrong. Never mind. I'll do a set background color. UI color, orange color. There. Gotta remember where I am. I'm in Objective-C. All right. I'm going to set the background color to orange because that's just going to be incredibly attractive. And then what we can do also is, actually I'm going to make this blue. So we can change things up and not have it be too obnoxious. and change this to blue, and then I'm going to also say the our button that we created, our button hello, which is the button that we pressed to start all this. Our button hello, we're going to set the title label color, set text color to be UI color, white color. All right. Ooh. So that's what you need to code to create a little alert pop-up with an OK button that changes your background color in Objective-C. And I'll go ahead and run them. Okay, so, oh wait, I never actually call it. Missing one line here. Down here, we need to call self present view controller. So we need to actually present this alert control we just created. And this is going to be alert. Animated is yes, because it just, that's the way it is. Nil for completion. So just for reference, Objective-C originally started off way back in the mid-'80s. They created this for the next step computer. So if it seems really archaic and weird, that's because it's been around a really long time. All right, now we have our missing thing. Hello there, hi from Objective-C, and for some, I never added the action. One other thing I forgot. In all the mayhem, I never added the, so we need to actually add the action onto our alert controller. Call add action, and that is the action object. All right, we're getting there. I have to stop that. One more time. Click OK, and now it's blue, and our button is white. So that was easy, right? Okay. No comment. Yeah, that's Objective-C. So now we have that. Now that we have that, we can call our, well, we'll first have to code it. But now that we've done an Objective-C call, we can combine that with a call to our Swift object and draw a ball somewhere on the screen. So that's the thing we'll do next. Is everyone following along so far, somewhat?
I got some sort of issue back on the view controller.
Okay. What do you got, Trevor?
The self.view set background color to the .view.
Okay, and down here?
No, under the UI alert action.
Oh, okay.
Yeah, that part right there has no visible at interface.
What was the full error?
No visible at interface for UI view declares the selector set background color.
Okay. Do you have that? You don't have it with like this, do you?
Hmm?
You don't have the dot notation, do you?
No.
Okay.
Ground. You're removing.
That it?
I've got another error.
Does that fix that line?
Yeah, I got
Okay.
that line.
Presenting. You're just typing too much.
Yeah,
There we go.
my auto-completion was working very well.
Yeah, well, it'll give you that presenting. It doesn't give you this guy right away because it's something like presenting view controller or something.
I'll get it.
All right, cool. Thanks, Valerie. All right, so we have a little alert that pops up with about only 40 lines of code. So that's Objective-C. Now we'll go back into our Swift view, back into the wonderful world of Swift. And here we'll go ahead and implement our draw ball function, draw a ball. So what this will do is we'll pass in these x and y coordinates and radius, and then it'll draw it out for us on the screen. All right, so back to Swift notation. We're going to create just a standard UI view when this guy's called. All right, we're going to create a frame. No Alex or nits here. We just do a simple constructor. X will be X. Y will be Y. Width will be radius. And height will be radius. And I'm missing a parenthesis. Okay. A little bit easier than Objective-C, but there it is. There's our ball. We're going to create a UI view. So we could, you might ask, why don't we just do what we do up here? Could potentially do that, but when we're not in the draw rect, so draw rect is basically drawing stuff out. When we're just calling this straight up, we have to actually create a UI view. So we're going to create a UI view and add it as a subview to the main view. So we can say ball dot, let's see, what do we end up for color behind us? Ball at background color equals UI color purple, maybe. Make this thing just as gaudy as we can make it. UI color a purple color. Then we want this to be round. So right now what we're creating is a square. So we're going to set the layer dot corner radius. It's going to need to be a factor of the radius. And I think that factor might be 2. It's probably not liking the fact that this is a float. Nope. It's a CG float. So this is how we're going to make this thing round. Ball at layer at corner radius equals CG float. So I'm going to self dot view. No, this is a view. Self dot add subview. Add ball. All right. So the reason why it's not self dot view dot add subview is that this is a view. This is our view inside our view controller. So we just call add subview on ourself because we are a view. And that should go ahead and add the ball wherever we want it. So now we need to call this guy. I'm going to do a product clean. So when you do a clean and build, that clears out all the intermediate files and does a complete build. So now with this, we should, if we go into our handy dandy file we created that links everything together. So if I go into my viewcontroller.m and go to the definition here, go down to my view. Here's our declaration of our method we created. So when we call this guy, this is how Objective-C is going to know about it. All right. So back in our view controller, we need to create another button. in our view controller that is going to be, we tap on that and it draws a ball. So if I go to my storyboard, I am going to go to this guy. I'm going to remove this constraint because I don't want it centered anymore. Because I'm going to have two buttons now. And so I'm going to set this guy to be like a set distance from the left side. I'll set it to be like 10 pixels from the left side. Then we also need another button to do our creation of our little ball in our Swift view. Drag a button over here. And I'll do the trailing space on this guy. And then we go up and set that to be 10 also, so that they're kind of equally spaced. All right. This guy's probably not going to, we don't really need an outlet for it, we just need an action. So I'm going to go up to my assistant here. And that's some little batch ugliness right there. That's not what I want. All right, view controller, here he is. We're going to create an IB action. All right, so down here, I'll just make a little room for it. We select our button and do a control drag. Insert an action. Call this draw. Draw a ball. So you a button, connect, creates our IB action for us. All right, so now, it's where the rubber hits the road. We're going to call our very own function that we created in Swift from Objective-C and see how we do that. We can say Swift view equals self.view, typecasting them. And with these Objective-C pointers, this pointer, this little asterisk guy can be right up tight against the type, or it can have a space after it, doesn't matter. If I remove it, like that, you get an error. And so if you ever see one of these, gives you a really nice error. Use type Swift view or arithmetic or pointer type is required. You're like, what in the hell is that? So that just means that it's not a pointer type. You need that. That makes it a pointer type. All Objective-C objects are pointers, except for the primitives, which are not objects like ints and floats and stuff like that. All right, so it needs to be a pointer type. And then we can call SV draw a ball, and there is our method that we created. And so now I need to tell it where to draw it. We'll say 200 in X, 200 in the Y, and radius of like, I'll make it a big ball. And there we go. And we're ready to run this guy. Okay, so do our first one, yay. Now we'll draw a ball, and there's our ball. Seems like it's a little far over, but I guess not. It's a 5S, so if it was a 6, it'd be a little bit more centered. All right. So we have created an Objective-C project, added a Swift class to it. So the first thing we did was we made the view, before we did any coding, we made the view that was inside our view controller a Swift view using the identity inspector. Change that to Swift view. So then that kind of hooked the two together. And then we went ahead and with the help of the bridging header information, we were able to create method calls on our Swift class and call them from Objective-C. We're also able to just call regular Objective-C methods from the view controller. So we can go ahead, we can create more view controllers that are either Swift or Objective-C, either one. So you can basically create any object at any level. Once you've got that bridging header linking the two languages together, you can pretty much create view controllers, views, buttons. If I wanted to create a custom Swift button, I could create that and actually plop that guy right on my view and use it. And it all just works. Not that you'd ever want to create an Objective-C project from scratch, but a lot of companies are going to have, like my company has thousands of lines of code written in Objective-C, and now we're adding Swift files to it. So I think it's a pretty common occurrence to find that scenario. Okay, so any questions? I know this stuff is pretty easy. All right, so there is no assignment, like I said, from this. If you guys have done this with me and you turn it in, I'll give you like 5 extra credit points just for turning it in. You don't have to do any modification to it. If you create like another object, another Swift object, and add it in, depending on the complexity of it, I can give you more points. But we'll see. Anyway, so that's basically it. There's no mandatory assignment from this. If you want to turn this in as extra credit, I think I can create like an optional assignment in Blackboard. It's not mandatory, and just assign a point value to it, and you can use that. Next week will just be open lab. You can use the time however you like. I'll be here like usual to like answer questions, help out with problems, that kind of stuff. So that's basically about it. So that's it. Last lecture of the semester. Hope you guys enjoyed it. Let's see, I'm going to find the recording here.